welcome back from lunch. My name is Steve Wallace. I work for Internet 2, and you're going to get a really good presentation from Brad Gorman at ARIN, but I just have a few things to say before Brad starts. It's audience participation. There's a URL you should go to. I know the wireless has been somewhat flaky, but if you can, go to this URL. The tiny URL says go-RPKI. If you go there, you'll see a list of about 1,000 networks. It's a searchable list. You can search for your network in there, search for the name of your organization. If you're in that list, great things can happen. If you're in that list, that means that your institution has everything in place to create a ROA, an RPKI ROA, to better protect your network. So if you're in that list, it means you haven't created one yet, but you're able to create it. And I am helpful. I am happy to be helpful in having you create that. And you can even send me an email, and I'll schedule a time, and we can create it together. And once you hear about how important it is, you want to do that. And speaking of how important it is, a couple summers ago, I was on vacation, and I got an urgent email from a network connected to Internet 2 saying, essentially, we remember you telling us about these ROA things. And some network in the Philippines is announcing some of our IP addresses, and it happens to be the IP addresses that are used for our state's top-level web servers. I can't say the name of the state, but imagine statename.gov. Those things went offline, and they said, you know, we tried to contact the network in the Philippines, and we couldn't get them to do anything. Well, there's no other tool to prevent this. So this can happen to any of our networks, and it can happen briefly. Someone can do this for minutes, so they can use your good reputation to spam a bunch of people and give it back. You may not even notice the outage. Or in this case, they used it for weeks, and fortunately, the effect was totally mitigated once they created the ROA. If you're in that big list, you're already paying for the service. You're just not set up to use the service yet, and I'll help you with that. So hopefully that had the effect of motivating some people that this is something that they could do to better protect their networks. And with that, I'll let Brad do the better part of the presentation.
Thank you, Steve. Yes, I'm Brad Gorman, fancy title, Director of Customer Technical Services, but I am the product owner for all routing security services, and RPKI is a special place in my heart. So we'll get right into it and see what it is. So I'm just going to quickly go over some of the fundamentals of routing security, and then point out ARIN's interfaces in our tool set, and then go over some best practices and lessons learned that networks, large and small, that have deployed RPKI before you, if you haven't done it yet, we've learned a lot, the entire community, and it's always good to take advantage of that and not reinvent the wheel or hit the same problems and errors that people have done before. So BGP is the protocol of the internet. I think we all know that. I mean, that's how, you know, networks across the world can communicate with one another. That's how our information is shared. That's how we buy things online. That's just known. There's no mystery in that, or no mystery. And BGP is what enabled the internet today, right? It was an information sharing tool, and it's transitioned over to, you know, a commercial tool. And when that happened, as that happened, it became more lucrative for people who wanted to do something bad to take advantage and steal traffic from you, your customer, you know, another provider. And that's why routing security is so important. So BGP doesn't know any better. BGP is the internet's GPS, right? It goes where it's told to go by the information that is available to it at that given point in time. Hopefully, that information's accurate. If you're if the database is old, you may get bad information on where to go. And if the information is corrupted in one way or not, BGP just does what it's told. So we had to find, as a networking community, find a way to avoid circumstances where BGP just could not think about, learn about, understand that it couldn't do anything other than what it was being told. So the way to do that is use, in this case, RPKI. Make statements for your resources so that the RPKI data set can be compared with what your layer 3 BGP networking device is speaking, and use both data sets to say, okay, I have a more useful tool and information available to me to make better routing decisions. So Steve was giving an example of how a institutional network was inadvertently, whether it was intentionally or not, their traffic was rerouted a direction that it shouldn't go. There are a number of examples of things like this happening. 2008, the government of Pakistan didn't want people within their country borders to be able to see YouTube. They were blocking the information that was being sent in from the out of the world. They were blocking the information that was going to the outside world. The way they implemented it, though, however, is they started drawing all of the YouTube traffic from around the world to Pakistan. And arguably, definitely, traffic was interrupted, but not just in Pakistan, but in many places around the world. And YouTube, service was certainly impacted by it. Examples of environments that are being, or that have been hijacked for financial reasons. In 2018, an organization took advantage of Amazon's DNS service, and for a very brief period of time, diverted traffic that was going to my Ether wallet. And they were able to capture, hijack the traffic from people's logins and get into their accounts, and lots of money was stolen. Again, BGP is just doing what it's told. If someone is successfully able to masquerade as announce your networks, and there's no other tool in place that's stopping it, it's just going to pass the traffic along. Another example of something that was just a fat finger mistake. Allegheny Networks, or Allegheny Technology, sorry, had a tool in place that was giving them more specific information to generate their routes and their traffic. But what they ended up doing was propagating those more specific routes that were, in fact, Verizon routes, drawing all Verizon's traffic to this little tiny little pipe network. Just a general misconfiguration that causes, a huge amount of impact. So these are the kind of things we have to be aware of and know that it's possible if you don't utilize the tools that are available to, mitigate issues like this. Routing security, it's pretty straightforward. It's not host security, it's not LAN security, it's making sure that your announcements and your reachability and your information, your services are reachable all the time on the internet. It is on the resource holder, you, to make statements about how you're announcing your prefixes to provide this information to others who are going to consume it and say, hey, this is information created by you, by the resource holder. I'm going to use that to better not only secure my networking, but networking for people further on down the line. So how do we secure it? Well, public key infrastructure, RPKI, a resource public key infrastructure. PKIs are common. PKIs are the same things that HTTPS uses. And in fact, RPKI uses the same HTTP error code or message codes going back and forth. It utilizes the same X509 encryption. Didn't want to reinvent the wheel. But it was a useful, cryptographically contained environment that could be utilized to perform routing security. And the idea is ensuring advertisements are accurate, verifying routing information that is being seen is in fact genuine, but it's not just an individual problem, it's a global problem to solve. So that's why all of us need to be aware and knowledgeable about what's going on and how to do this. So early on in the days of when routing security became a thing, that was the advent and the introduction of the Internet Routing Registries. Now, the IRRs have been around for 25 years, and there's a broad number, somewhere around 20 different IRR databases maintained by 20 different organizations that have information that is currently and will continue to be used to build policy based on this information that users have put in these databases. But the challenge is that not all of the information in these databases can be authenticated. I could, put information into an IRR that's free and just say, hey, put this information in there. And I can make a statement not only about my resources, but about yours. And there's no way for an organization to stop me from doing that. The current situation, the current environment, is that all 5 of the RARs, ARIN is the RAR for North America, the North American Internet Registry. All of the other regional RARs have IRR databases that are authenticated. We can, in fact, say these resources and these statements that were made by you, the authorized resource holder. So this is the beginnings of how the IRR is a useful tool that can continue to be used, but still there's this component that someone else could create information somewhere else. And this is really where RPKI works, where it comes into benefit. So definitions, I hate reading them, but effectively it is another method that is cryptographically secure way of a resource holder to say, these are my resources and this is how I am using them. And this data set, independent of what the internet looks like, can be used to establish a state of validity that can be identified as this is a good announcement to come towards. This is made by me, it is genuine, and we can move along and make things better. The flip side is, yes, you can make a statement about this, and when someone is either misconfigured or actively trying to hijack traffic or divert it to where it doesn't want to go, these RPKI statements can be used to stop that from happening, whether it's to mitigate or to actually shut the door on what they're trying to do. So how do you do it? In RPKI, those objects are called ROAs, route origin authorizations. And the method that's used is route origin validation is how ROAs are used to provide better routing security. So I'll go into it. So the fundamental steps of RPKI route origin validation is the authorization. That's these ROAs, and these ROAs are made by you, the resource holder, to say this is how I'm using it. I'm originating this prefix from this ASN. In the middle piece of it, there are open source software packages. They're relying party software packages, but validators, common term. And they're the ones that take this RPKI information from the RAR repositories and compare it with what it sees inside of the internet routing table and establishes that validity state. And then network operators use that information to perform origin validation and say, yes or no, this is good, pass this traffic along, drop it to the floor. Again, here's what a ROA is. You're saying, hey, these are my IPs, and this is the ASN that I'm authorizing as the origin. Plain and simple. And it is a message that anybody around the world can see, consume, use, and work with. The RARs are the entities, the organizations that have the authority to hand out addresses, and we're the ones that run the registries that, in fact, are the phone book, right? We're the ones that can say with authority, these are resources that are assigned to an organization or a university or an edge institution, and these statements are genuine. That's what the RARs can do. These signed objects, these ROAs, though, are the fundamental component of how RPKI works. So without ROAs, the benefit of RPKI just isn't there. So that method is, like I said, it's called route origin validation. So this is the first routing security feature that RPKI introduced, and it gave another secure, verifiable data set that could be used, or that can be and is being used to limit the impact of misconfigurations or attempted route leaks, hijacking, things along these lines. The thing is, route origin validation is not something that everybody needs to do. Odds are your upstream providers, Internet too, and other major telco providers, connectivity, ISPs, they are already performing this route origin validation process to limit the propagation of bad announcements across the internet. And as more and more organizations do that, there's less and less impact from these unknown or unauthorized events and announcements. And it isn't mandatory, but what is the key again is that ROAs need to be created. You need to make statements about the use of your resources. Otherwise, origin validation isn't very useful. So the key is only you can make ROAs for your resources, right? You're the only one that can make those statements. And if you don't, then it doesn't work. But what if you say, have a block of addresses that you're not announcing, but you're going to bring it to AWS or Azure or IBM or Oracle and say, hey, please announce these networks for me. I don't have an infrastructure in place. I'm going to buy other services from you. So this is a case of you're not originating it from your ASN. Doesn't make any sense, right? But that organization, when they send traffic out, will be representing themselves as the origin. So when you create a row, you need to identify them as the origin. You own the prefix. You are authorized to use the prefix. You know where it's being used, so you have to make those statements. AWS can't do that for you. Microsoft can't do that for you. There are also examples where there may be a requirement by a DDoS provider. You may have a requirement that says we need to have these ROAs in place to provide your service in time of need. So there are cases and examples that not everything is a one-size-fits-all scenario. So you have to be aware of these specifics, and as you move forward and create these ROAs, you need to understand. Now, the ARIN interface, I'm just going to give you an example real quickly of what it looks like and show you how easy it is and the few steps that it takes to just create a ROA. It's very simple to do. So if you don't already have one, if you're not linked to an organization, this is the front page to log in, opportunity to create a user. When you log in, this is the user dashboard. Everybody will see this. It identifies the number of resources you have, the number of ASNs, the number of organizations that you may be linked to. Some schools, some institutions, some commercial organizations have multiple ARIN organizations with resources allocated to them. So you have to be, this is what's available to you, and where you start going and making those decisions. But I want to call out very quickly, there are 2 RPKI environments at ARIN. Aside from the ARIN Online live environment, there is a test environment, the OT&E. And the OT&E is a functional duplicate of our production environment. So you can go in and test your configurations, test your automation, test your tooling, even use that information in the RPKI repository of this test environment to verify that what you're about to do is going to have the expected response or the expected impact. And this is absolutely key. Understand that this is here and make use of it. We've made it available to all of our membership. Highly recommend, please use it, use it. Because that way you get comfort knowing that what you're about to do is going to result in the intended outcome. So once a customer signs in and you see access, this user account has access to 2 ARIN organizations. If you haven't already signed up, there's a sign up link. There are 2 different types of RPKI. There's hosted and delegated RPKI. The vast majority of the world, and I'm talking 98% of the world that uses RPKI, whether it's small or large organizations in northern, southern, eastern, western hemisphere, use hosted RPKI. The reason being is all of the heavy weight is taken on by the RAR. We run the certificate authority. We maintain the repositories. We maintain this high availability infrastructure, and all you need to do is create your ROAs. The flip side is a delegated configuration that there is much more hands-on required by you or whomever is going to run this. So the recommendation, unless you have a specific requirement put upon you, recommendation would be hosted RPKI. Once you sign in, once you register, here's an overview page of what you're going to see. It gives you an example of where you can go and see what your resources are that have been allocated. Now, resources that are have to be eligible to use our RPKI services. And what is eligibility? Eligibility is based on you have been allocated these addresses directly from ARIN. You haven't been reallocated them or reassigned them from another entity. And these resources need to have coverage by a registration services agreement, an RSA. So those are the two main requirements that go in to use RPKI at ARIN. But there is no fee to use RPKI beyond what your membership fees are. It's a free service to use. They're the basics of looking what's in the table of ROAs. It's just an example of what they might look like. Creating a ROA, it's a very, very simple form. The information that you absolutely positively have to have in a ROA is what's the origin network and what's the prefix. That's it. Everything else is under the hood. You don't need to put in anything else. There are two optional fields that we have inside of our form. It is a max length field, which is another component inside of a ROA that's in the standard. And there are reasons why you don't want to use this. I'll go into a little bit, hopefully very quickly. And then a ROA name. The ROA name field isn't a standard field, but it gives humans the ability to understand why was this ROA created. And you can read it at 1 o'clock in the morning when you're tired and something's going on and understand, hey, why is this going on? Once you go in and put information in and say, this is what I intend, this is what I want to do, you get to review. And then as soon as you review, it's done. Puts it in the table, and you can move on and create more ROAs for your resources. You can create multi-prefix ROAs. Every ROA doesn't have to have one origin to one prefix pair. You can have multiple prefixes coming from the same origin. So you can reduce the number of ROAs that you have associated with the information about prefixes in your announcements that are going out to the internet. Same steps going through to submit, and then again, the ROA table is updated with what you've just done. I'm going to zoom through some of the rest of these slides here because it's going over how, I'm not going to zoom through these slides, sorry. So best practices and lessons learned, I brought these up earlier. And I brought up max length as well. So if I have a set of prefixes and I have a large aggregate block, some people remember them as a /B, or a class B network or a /16 CIDR network. I don't want to go through and create a ROA for every single one of those prefixes, or I don't want to put those lines in there. I can use this max length variable and say everything from my 16 to the longest net mask match is valid in this box. It's very simple, easy to use. But as time has gone on, what we've realized is, hey, you are exposing yourself to a vulnerability that's called let's try it again, a forced origin subprefix hijack attack. So if you pre-authorize every single one of those possible completions of your /16 down to a 24, you're saying 511 networks. If you see this match, it's valid. But if you're not announcing them, and somebody else does, and masquerades as your ASN, their traffic gets passed along as being valid. So you may need to use it, but use it very carefully when you do max length. Five? Okay, I'll zoom through as fast as I can. Another one of the best practices to understand is create ROAs that match your announcements. This kind of seems intuitive, but if you don't think about what you're announcing and the information that you're putting inside of a ROA, you may invalidate the announcement that you're currently sending. So take advantage of what you see today, what you're announcing today, and match that when you go to create a ROA. So that scenario will keep you out of trouble when we start implementing RPKI. Because the problem is, or the lesson learned is, you can reduce the number of ROAs that you create, and it saves time, but that is limiting you to the exposure of hijacks. There is a very good catch here. Make sure that when you're creating your ROAs, you create them in the right order. What does that mean? You have a /16. You're announcing pieces of that /16. And you go, hey, I'm going to create a ROA for my /16. And the very first time you do that and say submit, every one of your more specific announcements goes away. Why? Because the statement you just made was this 16 is valid, and everything else is not. So what you need to do is make sure that you create ROAs and prefixes and those origin prefix pairs from the most specific back to the aggregate block. Everybody has been bitten by this, guaranteed. Big organizations, small organizations. This is really one that you need to pay attention to. And then another specific thing to ARIN is we don't allow duplicate ROAs to be put in place. So if there is a prefix origin pair, that's what the meat is, already in existence, we don't allow you to create another ROA that matches that prefix origin pair. You'll get an error when you do it. Why am I getting this error? This is why you're getting this error. This is my resource. Why can't I put it in? It's because it's a duplicate. So, familiarize yourself with the tools and how it works. The key when you're deploying RPKI, whether it's the first time or as you continue, plan out your deployments. Know what you're trying to do. Understand what these configurations are going to do, what they mean. Know that RPKI is not a magic bullet, and it doesn't instantly flip a switch to work. It takes time. You could create a row and it might take up to 60 minutes before the whole internet has learned about the impact of you creating a ROA. So it's a great tool, but it is not a one-stop shop of being able to protect you and your resources. These next two pages literally are links of tools, and yes, documentation is a tool too, where you can go and learn and understand, interface with the community, get pictures of what your presence on the internet looks like, what your RPKI status looks like, where you can see and verify what you're doing is working or not, what you want to do. That's it. So, routing security at ARIN.net, that is me and my team. You can always come through and ask questions. No question is too big or too small. And the ARIN website has a great amount of resources available to it, whether it's short videos or hour-long plus webinars. Please come by and look. You all come to Steve, and Steve's available to you. Steve and I work together. If you have specific questions to ARIN and how it works, both of us can probably answer this for you. So thank you very much.
Any questions?
So once we start, adopting ROAs much extensively, do you think that malicious entities would start advertising their ASNs as the intermediate ones instead of the origin ones?
So if I heard you right, you were talking about if someone starts originating traffic from an illegitimate ASN that does not match what's in a ROA, or?
I mean, let's say now if something is originating with a malicious entity, we know that it's not supposed to originate from that.
Right.
So we discard that. What if it is in the intermediate AS parts? So the origin ASN remains the correct one, but the malicious entity adds it to the next level.
Okay, so with origin validation, it's literally that, the originating ASN and the prefix tied together. What you're talking about is really the next knob that's coming out of RPKI. It is called an ASPA, it's Autonomous System Provider Authorization. And what that is a statement that you're making to say, this one hop is a valid path. So when it looks at the full path back to the originating ASN, if this doesn't match in this step, then it's an invalid path. So path authorization and origin validation are going to be two pieces that come together, make RPKI even better, close that vulnerability surface or attack surface even more so than it does today.
Okay,
Did that answer your question?
Yeah.
Okay, good.
So my question, and if it's not quick, we can just forget about it
Sure.
for now, is about revocation. And if you've got like a multi-prefix ROA.
Yes.
And you wanted to revoke one of those. Does that make it harder, I guess?
No, actually it doesn't. So earlier this year in May, we implemented the Edit a ROA tool. So you can go through and selectively pluck out or add in prefixes in or out of your rows. You can change your max length value. The only thing you can't do is change the origin ASN, because that's the one thing that's immutable inside of a row. If there's only one origin ASN, there can be multiple prefixes. So yeah, you can be selective about it. If you want to go and get rid of everything in a row, you just go and delete the row. You can't manually go through and pick every line and say, oh, this row is gone. We'll stop you from doing that.
Okay, thanks a lot. If there are no other questions, or you have a question? One more?
And if there are any more questions, the ARIN help desk is over by the tower elevators. Please stop by and I'll be glad to answer them.
Yeah, I just thought it might be interesting for you to give a sense of how strictly is the validation happening at this point in time. You know, a couple of years ago, hardly anyone was doing it, and we've really come a long way. So yeah, this might be more of a question for Steve. I see him standing.
If you announce a prefix that is deemed invalid, most of the tier ones, most of the RNE networks are going to drop it. So you will have a very small internet. So it's very aggressive. It can take up to 2 hours for the ROA to propagate fully, but typically you see activity in minutes. So yeah, it's pretty, you know, you don't have much internet connection when you do that.